Let us see types of HVDC transmission system. In types of DC link having three types. One is monopolar system, bipolar system, back-to-back connection. Come, let's go with monopolar system. In this monopolar system has one conductor usually of negative polarity and uses ground or C return. Sometimes metallic return is also used. Example, submarine cable transmission system. Then bipolar system transmission. This bipolar system transmission having two conductors, one positive and other negative. Each may be a double conductor in high voltage direct current lines. Each terminal has two sets of converter of identical ratings in series on the DC side. Then the junction between the two sets of converter is grounded at one or both ends. Normally, both poles operate at equal current and hence there is zero ground current flowing under these conditions, these bipolar conditions. Then we have to see homopolar link, but I am not mentioned in that classification this word. But I have to use this word. Homopolar link has two or more conductor all having the same polarity, usually negative, and always operated with ground or metallic return. Because of the desirability of operating a DC link without ground return, the bipolar links are most commonly used. Homopolar links has the advantages of reduced insulation cost, but the disadvantage of earth return outage is one of the advantage. Instantly, the corona effect in a DC line are substantially less with the negative polarity of the conductor as compared to the positive polarity. The monopolar operation is used in the first stage of the development of a bipolar line, as the investment and converter can be deferred until the growth of load which requires bipolar operation at double the capacity of the monopolar link. Then we have to see another topic of back-to-back connection. This is nothing but usually bipolar without earth return. It has two converter session. One is converter 1 AC1, another one is converter 2 AC2. The AC1 acts as a converter of inverter. AC2 acts as a converter of rectifier. So those two converter and inverter are located at the same place. Both this converter session in between of both this converter session there is no HVDC transmission line or link because it has to provide asynchronous tie between two different AC network. So power transfer can be in either direction. That conversion from AC to DC rectifier station and from DC to AC inverter station are performed. A point-to-point transmission requires two converter stations. The role of rectifier and inverter station can be reversed of resulting in power reversal by suitable converter control. Very beginningly, we had been joined this HVDC transmission of rectifier station and ending to inverter station. This is most important point. So, okay, next topic is multi-terminal system. On this multi-terminal system having more number of converters and inverters, that means rectifiers and inverters, three or more terminal connected in parallel Some feed power and some receive power from HVDC bus. These multi-terminal provide interconnection among three or more AC network. That interconnection word saying variable rectifier station and various inverter station. Along with this connection and explanation, connected and relevant space like seashore area, hill station, and rural areas. So, in kind of areas, this multi-terminal system is most preferred one. Then, how HVDC works? We have to see the black diagram or basic diagram of HVDC system. Sorry. This HVDC black diagram having one rectifier station called a terminal A converter, another one is inverter station called a terminal B converter. Both this conversion unit connected across their representation place. Terminal A converter station, that means rectifier station, receive the AC power from which the generating station exhibit their power level. Then this AC fed to terminal A and which is converted by their own of DC. This conversion of DC which is feed to HVDC transmission line, that's called DC line. This HVDC transmission line transmit their entire power into terminal B converter, that's called inverter station. After the inverter station, we have to receive AC power according their performance level. This AC power adapted to filtration and which is give to the distribution panel. This is basic diagram of HVDC system. It's simplest explanation and simplest layout diagram for understanding purpose. So the rectifier and inverter station having various pulse converter bridge valves. Laterly we have to see in the remaining class, next class.